This is Module 10, examples 6 and 7. We'll start on page 192 with example 6. So example 6 is about using the one sample t-test on the TI calculator. Heights of people the same gender and similar in age are approximately normal. You know from government data that the mean height of young men is 69.5 inches, and standard deviation of the heights of young men is about 2.8 inches. Suppose that the mean height of all male students at LMC is 70 inches. If you choose 250 male students from LMC to measure heights, what's the population and what's the sample? So here we're thinking of the population as being the heights of all young men. So we can say the population is the heights of all young men. And we can assume we're in the US or in the whole world. And the sample is the heights of 250 male LMC students. Part B. You are fairly sure that the mean height of male students at LMC is greater than the mean height of all young men. Carry out a hypothesis test for this claim. Step 1, state the hypotheses. So we have to define mu naught, x bar, the null hypothesis, and the alternative hypothesis. So mu naught is the population mean, so that's 69.5 inches. X bar is 70 inches. Our null hypothesis, h sub 0, is that the mean equals 69.5 inches. So remember, with the null hypothesis, it's always saying there's no difference, so we use equality to set up the null hypothesis. So if the LMC students were not different from all male students in the US, the null hypothesis would be that the mean of the heights at LMC is 69.5 inches. Our claim is that LMC has a greater mean height for young men, so our alternative hypothesis is that the mean is greater than 69.5 inches, meaning the mean for LMC students. Step 2, let's collect the data. So we're going to calculate the sample standard deviation for the male students. And so here, S sub x equals 2.8, and then we have to divide by the square root of the sample size. So we divide by square root of 250, and you can check on your calculator. That works out to be 0.177 inches is the sample standard deviation. So now we want to assess the evidence. So we're going to use the graphing calculator. You could also use the formulas in the front of this section and work it out by hand, but it would take a lot longer to find the t-score and then the corresponding p-value. So remember, the t-score is analogous to the z-score in that it's going to tell us how many standard deviations out our sample mean is. The difference is we use t when we've got a sample and z if we're dealing with the whole group or the whole population. So we're going to go to stat and choose test, and then we're going to choose choice 2, the t-test, because we're using sample data. So let's go over to the calculator and do this. So we go to stat, arrow over to test, and we're doing the 2 sample t-test. The 1 sample t-test. So we're going to do choice 2. Okay, so we want to put in our statistics. So arrow over and press enter so that we're on statistics. And then our mean that we're comparing to is 69.5 inches. And our sample mean from LMC students is 70 inches. And I'm clearing out the numbers in here are the data that we had from earlier calculations. S sub x is the sample standard deviation, but in the TI calculator, you can put in the population standard deviation of 2.8 inches, and then it will do the calculation for us. So we can say n is 250 male students. So knowing that it's a sample, it's going to take care of dividing by the square root of 250. And so now we want to go ahead and set up our claim. The claim here is that LMC students are taller than 69.5, so we can arrow over and select greater than mu sub 0. And then we arrow down to calculate. And we get that T is 2.8234. So we know that LMC students are more than 2 standard deviations away. And our p-value is 0.0026 if we round it. Okay, so remember the TI calculator took into account that the sample size was 250 and divided the standard deviation 2.8 inches by the square root of 250. And so that's how we know that we're more than 2 standard deviations away. If you put in the sample standard deviation that we already calculated for S sub x, it's going to count the sample size 250 double, and you're going to get a super small p-value. So when we enter it in the calculator, make sure you put in the population standard deviation here and just let the calculator know the sample size. Okay, so we record here our t-value is 2.8235. This is more than 2 standard deviations away. And our p-value, remember, p is the probability that the null hypothesis is true, is 0.0026. So this is a small p-value. It's less than 1%. It's definitely less than 5%. So remember, when the p-value is less than 5%, we say it's a statistically significant difference. In this case, we'd say that the LMC male heights are statistically significantly higher than the population mean. So step 4 is where we state our conclusion, and we're going to use this p-value to make our decision. So the p-value is small, less than 5%, which we write as 0.05. So there is enough evidence to reject the null hypothesis, and the sample does support the claim that the mean height of male LMC students is greater than all young men. So again, because I didn't state a alpha value to compare the p-value to, the default is always comparing to 5% or 0.05. That's the default we choose in statistics. So if the problem doesn't say, assume you're comparing to 0.05. And this 0.05 is a value that statisticians chose in the 1920s. One statistician, when he was writing one of the first books about statistics, said 5% was a good level to choose for rejection. And so statisticians have stuck with it ever since. So it's a nice number. It gives you, just 5% outside of your interval, but there's nothing super special about it. Okay, example 7, we're going to use a 2-sample t-test on the TI calculator. So we're going to compare 2 sample groups. In a recent study, medical doctor James Levine and his collaborators at the Mayo Clinic investigated the link between obesity and energy spent on daily activity to see if non-obese subjects are more active. For the study, the doctors chose healthy volunteers who identified themselves as not exercising regularly, collected data, then sorted by obese or not obese. A random sample was chosen, and the minutes per day of activity were measured. So our mean here is measuring minutes per day of activity. And the first group, the not obese group, has 9 members. And the mean is 525.751. The standard deviation is 107.121 minutes. The obese group had 11 members, and the mean was 373.269. And the standard deviation was 67.498. And here's our hint. Because we have 2 samples, we're going to use a 2-sample t-test. So let's state our mean and then our 2 sample values and our null hypothesis and our alternative hypothesis. So when we talk about a null hypothesis with 2 populations, we're talking about the 2 populations being the same, meaning there's no difference between them. So the way we define the null hypothesis is we say the average minutes per day is going to be 0, or having difference 0, meaning no change. So the idea is if we said population 1 minus population 2, they're not going to have any difference in the minutes per day that they exercised. Our sample mean X1 is 525.751 minutes for the not obese. And this X should have a bar on it, but I couldn't typeset it on the computer. And then X2 bar, our sample mean for the second group, is 373.269 minutes for the obese group. So our null hypothesis is going to be that the mean for group 1 is equal to the mean for group 2. Again, if we subtracted them, you could write it as mean 1 take away mean 2 equals 0, right? So saying the two groups are equal is the same thing as saying group 1 minus group 2 equals 0. And then our alternative hypothesis is that group 1 has a bigger mean than group 2. So again, we often will see this written as mean 1 minus mean 2 is greater than 0, meaning the difference is bigger than 0, meaning group 1 was larger. So let's calculate the difference in sample means. So if we say sample mean 1 minus sample mean 2, we'll calculate 525.751, subtract 373.269, and we get 152.482 minutes difference. So we see that there is some difference. We need to investigate if this difference is statistically significant. So we're going to assess the evidence using our graphing calculators, or you could use the formulas from the front of this module, but it would take a lot longer, to find the t-score and the corresponding p-value. Again, remember we're using the t-score because we're using sample data, and so the t-score is going to tell us the number of standard deviations in the same way that the z-score would. So we're going to go to Stat, Test, and then we're going to arrow down and choose Choice 4 for two-sample t-test. And then in our class for pooled data, we're always going to choose No. So let's go over to the calculator and see how that works out. I'm going to clear out my previous screen. I'll clear out my key history. And I'm going to go to Stat. I'm going to arrow over to Tests again. And remember I gave you a green sheet with all the test menu information on it? So your list of all these tests is on that sheet, and you can refer back to which test does which on your sheet. So we want test 4, which is the two-sample t-test, because we're working with two samples. And we're going to put in the statistics, because we have the statistics and not lists of the whole data. So X1 is the sample mean for group 1. So that is 525.751. The standard deviation for the sample group 1 is 107.121. And the first group has sample size 9, so N1 is 9. And again, I chose the first group because it was first in the list. It doesn't really matter which group is group 1 and which group is group 2 as long as I keep track of which way my inequality should go. Okay, so I've got the sample mean in there for group 2. The sample standard deviation for group 2 is 67.498. And then group 2 had 11 members. All right, and now we've got to set up our claim. So we're claiming that the inequality is greater than inequality. So I'm going to go over and make sure that mean 1 is greater than mean 2 is highlighted. Always leave pooled on No for our class. And then I'm going to go highlight calculate. And we see here our p-value is 0.0013 and our t-value is 3.71. So we see there's more than 2 standard deviations difference for the sample data, and our p-value is much less than 5%. So our p-value is 0.0013, and we can make a note this is a very small p-value. And our t-value is 3.71 standard deviations. So anytime we see a t-score or a z-score more than 2, we're thinking there's a statistically significant difference. This is more than 2 standard deviations out. Now we're going to use our p-value to make a decision and state our conclusion. We can say the p-value is very small, so there is enough evidence to reject the null hypothesis. The sample does support the claim that non-obese subjects are more active. Okay, so again, to reiterate, the reason that we are able to reject the null hypothesis is because our p-value is less than 5%, We didn't have an alpha level stated here, so when there's no level stated for comparison, we use 0.05 for comparison. Okay, you're going to do some similar calculations in the group problem and in the homework assignment. So remember to post any questions to the discussion board.